Restart now because of the frickin' details. Give him another warning. Hello and welcome back to IXL Tutorials. This is Mr. Duffick, and today we are going to continuing on with Symmetry with IXL 02 and specifically with rotational symmetry. So we worked on some linear or reflectional symmetry last time for 01. This time we're going to rotational symmetry. And rotational symmetry is just if you chose a point, let's say the middle of this butterfly right here, and you rotated this butterfly, at some point it would overlap on itself perfectly. Now keep in mind, if you rotate anything for long enough, it's going to overlap on itself perfectly, because a full rotation, if you rotated this thing one full revolution, one full turn, it of course is going to rotate on itself perfectly. So rotational symmetry is referring to if it overlaps on itself anytime before a full rotation. So at a 90-degree turn, at a 180-degree turn, or something like that. 360 doesn't count. So just like with the last IXL for 01, they give you a bunch of objects here instead of shapes, which tends to throw students off, and even myself sometimes. Sometimes you might try to rotate something, and it looks like it's going to be have rotational symmetry, but there might be some pattern on here or some detail, like the dots on this wing, on these wings, for instance, that it does not count. And so even though the shape itself of the butterfly has some form of symmetry, the object would not be symmetrical because of certain features. So just keep an eye out for this. Now, that being said, this butterfly, if you were to rotate it around its origin, it doesn't really have rotational symmetry, right? Because if you flip this over a quarter, that definitely is not overlapping on itself. If you flip it over another quarter or just a half turn, now it's just upside down. And then you'd have to rotate it, one full rotation for it to be overlapping again, which doesn't count. So it does not have rotational symmetry. Good. Okay, does this have rotational symmetry? Oh yeah. You can turn this in the very small amount here, very small degree of a rotation, and this will overlap on itself perfectly. Everything's the same color, everything's the same shape, so it'll in fact it has several points of rotational symmetry, right? So yes, it does. Okay, which has rotational symmetry? So these are some of the details I was talking about, like the gems. Stay away from those. They're clearly different, so they're not going to overlap on itself. But even so, if you put a rotational point here, like a hinge point, and you rotated this thing around, you can see it does have rotational symmetry, right? In fact, it has 4. This one does not. You can flip it upside down and everything. It's never going to overlap on itself perfectly. And this thing right here won't do that anyway, because all of these details right here, there's no way that's going to overlap on itself. So it's going to be the first one. Does this picture have rotational symmetry? No, it does not, no matter where you are putting your points of symmetry. And again, it gets confusing when they have details like this or anything over here. I don't know if they're referring to just the image right here or the entire picture. I don't know, but either way, it looks like there is no rotational symmetry no matter where you put your point of rotation. Okay, which has rotational symmetry? Not this one, not this one, and this one does. It's literally a gear, so that is definitely going to have rotational symmetry. Does this have rotational symmetry? Well, if you look at all the details, it might. It looks like it does. It looks like it has a few. So we're going to say yes. Good. And etc. So let me jump a level and see if there's any. Okay, so the image has rotational symmetry. What is the smallest number of degrees you need to rotate the image or to look the same? Okay, so there's a very clear way to solve these kinds of problems. So think of like a square or a pentagon or something with actual corners or sides, like any standard shape. All you're going to do is, a full rotation of any shape or object is going to be 360 degrees. So you're just going to count the points or the sides. In this case, I would just count the points of our sun right here and divide that from 360 to get how many degree, the degree value. So we'll start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 different points it can rotate on. So if we do 360 divided by 10, that's just 36. So I'll type in 36. And that's just saying if we do a 36-degree turn, that'll overlap on itself. 36-degree turn, overlap on itself, etc., etc. So we'll do that and submit. Good. Okay, here we have 4 different objects or different details here, 4 points, whatever you want to call it. So what is the smallest number of degrees? Well, 360 divided by 4 is 90. So a rotation from this point to this point, for instance, which is going to be the first time it has rotational symmetry, is going to be 90 degrees. Okay. Let's see. What is the smallest number of degrees? Okay. Well, remember, not the shape, but the lines. Keep in mind the lines. And so we rotate. It's really only going to overlap on itself perfectly after a full half degree turn. So half of 360, half of a full turn is going to be 180 degrees. Okay, same exact thing here. You're going to have to flip it a half turn and then it's going to overlap on itself. You could also think of it this way. An entire rotation is 360 and it has 1, 2 corners, quote corners or details. So that's just going to be 180 degrees. Okay, and that is where I'm going to stop.